every rocket that launches is part of an experiment comparing the predicted flight with actual flight. This is critical in the science of rocket flight testing. And it is an important part of your First Nations launch competition. You will need to run simulations to help design your rocket and predict how your rocket will behave. RockSim is a simple but comprehensive software that allows you to design a rocket from a database of hundreds of rocket kits and components, then simulate its flight with various motors and weather conditions. It is similar to tools used by NASA flight engineers. By learning RockSim first, you can test and refine your designs before you spend money on kits or start your build. You can compare components, check your budget, and plan your rocket strategy. It will save you both time and money. And because RockSim is so popular, there are many online tutorials. And we've used the software for years. You can easily download RockSim for either PC or Mac with a free 30-day trial. Once the program is installed, open the RockSim program. The first time you open the program, RockSim may prompt you to do a database merge. Click Yes to all. Then you'll get a pop-up screen telling you there are so many days remaining in your trial period. Don't worry, once your team budget is available, you will be able to purchase an official license. RockSim provides a TARC temporary license option to FNL team members who prefer purchasing individual licenses. The temporary license may be used from September 1st through August 31st, and your First Nations launch grant will cover the cost. Just use your FNL award number for the TARC team number. Make sure you pay the licensing fee using your FNL funds. If your team selects the school site license option, you will be able to load and operate RockSim on 5 computers. So pick those computers carefully and make sure that most of them are portable so that you can bring them to the competition. Then you can launch RockSim anytime you like. We recommend that you run lots of simulations and explore all the program's features. The main screen of RockSim is pretty simple. It is divided into 2 areas. The upper area contains the main menu and additional tabs for data entry. The lower area shows you a 2D or a 3D rendering of your rocket design. Most of the real work is done in the upper area, where you will be able to enter and modify the specifications for each of your rocket components. Typically, for the new student, rocket models are loaded from the RockSim database. The database contains a large amount of existing rocket models. Once you are more experienced with rocketry, you can create rocket models from scratch in RockSim. Be sure to explore the Design Attributes and Design Components tabs, where you can inspect your model's component data and make changes later in design. You will also need to use the Prepare for Launch function and the Simulation Properties tab. This is where you will select and load the rocket model's engine, sometimes called motor, and adjust your simulation's flight conditions prior to launch. You can run your simulation once all your inputs have been entered properly. It only takes RockSim a few seconds to complete the calculations. 2 important RockSim calculations you will want to calculate for the competition include the rail exit velocity, which is simply the speed your rocket will be traveling when it clears the launch rail, and the descent rate upon landing. RockSim will summarize the results of the simulation in a nice tabular form for easy review. You can see data such as max altitude, max velocity, max acceleration, time to apogee. The Simulation Results tab can be configured to display whatever information you deem important. RockSim will allow you to view a 2D flight profile, where you can time step through the entire flight while observing the performance data at each time step. As you learn to interpret the results, you will see that the very sophisticated math behind the program allows you to create very detailed simulations. RockSim will also allow you to plot the various data. This is a handy feature to use in your reports, if you want to show the motor thrust curve or the altitude as a function of time. The results of your simulation can be run as reports or displayed as trajectories or graphs that can be visually interpreted to ensure you satisfy all safety and design requirements. If your simulation does not satisfy requirements, then modifications to either the simulation conditions, the motor selection, or the recovery specifications should be made, and the flight simulation repeated. If the results still do not satisfy requirements, then perhaps a different model or component should be considered. Other important simulation features include mass override and coefficient of drag, CD, override. Mass override allows you to input a total mass and center of gravity for a rocket that is already built, when it may be difficult to weigh each component. Mass override should be turned off, however, which allows RockSim to calculate each component mass based on material density and size. Coefficient of drag override allows you to input the coefficient of drag value for each component, if known. It is preferred you allow RockSim to calculate the coefficient of drag at time of simulation. You must check the calculation box. RockSim will also let you model your recovery system. Just as drag and aerodynamics are calculated to structural rocket parts, streamers, drogues, and parachute recovery systems can be modeled. Flight tracking will simulate single and double deployment rockets and even allow you to try to predict landing sites. In the proposal and preliminary phases of the First Nations launch, your team should run many simulations, examining as many kits as possible to determine the best kit-motor-parachute combination that will satisfy requirements. Once the kit arrives and the build progresses, keep in mind that modifications will be made in order to accommodate your challenge payload and solution. It is a good idea to regularly update the simulation to match your existing rocket, to ensure any changes will not violate vehicle performance requirements. There are various parameters that are important to understand for rocket flight. A few of these are drag, weight, and stability. Drag is the aerodynamic resistance of air as it flows around every exposed part of the rocket. You can change the drag of your rocket by polishing the surface, using a boat tail or reducer, or reducing any protrusions into the airflow. Ensure your simulation airframe finish matches your expected design for the most accurate results. Something to note: initial simulations typically have a margin of error in accurately predicting the final weight of your fully loaded rocket by plus or minus 10%. Drag considerations will also likely be slightly off. This means that your predicted altitude may also be off. So when your rocket is complete, you will need to carefully weigh and measure it. If the rocket is heavier, you should have already simulated a slightly more powerful motor as a backup. Keep in mind there is a deadline for motor selection, after which you can no longer change the motor you will be using for competition. You should also try to determine your payload design early, because payload weight and size are often overlooked in the build process. You can get into trouble if your payload breaks your weight limit. One of the most important things the simulation will tell you is the stability of your rocket. Stability is a measure of how your rocket will behave in flight. It is determined by the aerodynamic properties and distribution of weight of your rocket. RockSim determines stability by calculating the center of gravity and the center of pressure. Center of gravity is the average of all of the weighted components in the rocket. You can physically find the center of gravity by balancing the rocket. This can be done by hanging it from a string or by setting it on a straight edge. The simulation calculates the center of gravity using the mass and density of the different components specified in your model. Center of pressure is an approximation of the single point at which all of the aerodynamic forces act on your rocket. Calculating the center of pressure requires complex calculus. Luckily, a NASA engineer, Jim Barrowman, did all the math in the 1960s, and RockSim takes all that math and calculates the center of pressure for you. We suggest you use the Barrowman equations in RockSim. If the center of pressure is aft or behind the center of gravity on your rocket, then it will be stable. But if the center of pressure is forward of the center of gravity, then the aerodynamics will make the rocket unstable and dangerous, since wind can push the center of pressure forward. It is possible for a rocket to be stable in no wind and become unstable in higher wind conditions. Also, both center of gravity and center of pressure will change as the motor fuel is burned in flight. Luckily, the center of gravity generally moves forward as the solid rocket motor burns, causing the rocket to become more stable. For the competition, you will need to mark your airframe with the center of gravity using a crosshair and the center of pressure using a bullseye as shown in RockSim. Make sure to mark the actual center of gravity found by testing, not the simulation center of gravity. A rocket that is stable will fly fairly straight, oscillating in reaction to the forces of wind and drag. A rocket with minimal stability will follow a flight path that is more erratic and reactive to wind and drag. And an unstable rocket may fail and begin flip-flopping through the air. Needless to say, this can be extremely dangerous. You will want to verify in RockSim that your stability of margin is greater than 1 and that your center of gravity is forward of your center of pressure by at least 1 diameter of the rocket. There are a variety of other settings you can use to enhance your simulation, like smoke animation. But the most important thing is to understand how your simulations can inform your decisions at every step of your process. To recap, RockSim is the simulation tool that First Nations Launch uses to design and simulate rocket flights to ensure safety. There are other simulation tools, and you are welcome to try them as long as they conform to EEE requirements. But remember, all design reports must include a RockSim file. Learning RockSim and running many simulations early can help you manage your budget and solve many design issues. Don't be intimidated by technology. We are here to help you. Teams in the past have often waited too long to incorporate RockSim into their projects, so start early, even before your proposal if you can. There's a vast database of kits and components already pre-built for RockSim which you can use as a resource. And once you are informed by your simulation, you need to verify weights and measures of each component to see how closely it conforms to the simulation. Never assume the database is right. And while aerodynamics and center of pressure are hard to test without a wind tunnel, definitely make sure that you physically check the center of gravity. One last tip. Clever use of simulations can serve as a real advantage in this competition, and we not only recommend you learn and apply RockSim, but we'll help you. All you have to do is ask. And don't forget to refer to the competition handbook. There are links to more in-depth RockSim webinars and training videos. Thanks for watching this introduction to RockSim training. See you on the simulated range. The guidelines in this video are provided by EEE Wisconsin Rocketry Association, host of the First Nations Launch Program at Richard Long State Recreation Area. When launching locally, please check with your local TRA prefecture or NAR chapter.